Problem 26 and the list of the set of problems to review for the final exam. And you'll notice that this one is also an exponential function type problem. In this case, what we're going to be dealing with is a decay or a decline that is happening at an exponential rate. If you've watched the video for the preceding problem number 25, it was just the opposite. It was for an increase, exponentially increasing situation. Just want to remind you of just the characteristics of these exponential functions, and this is just one of the PowerPoint slides that's in the MyLab material. And I want to just point out that the value of the base, if it's greater than 1, then we have an increasing function. If the base is, notice carefully now, if the base is greater than 0 but less than 1, we have a decreasing function. Now, what sort of values do you find between 0 and 1? Well, you find fractions, right? Notice that the base cannot be a negative value in these. So don't get confused with that, because what we're about to see is them use a negative exponent on e, which will in fact cause, when we write it with a positive exponent, would cause that to become a fraction. So let's just look at that for a second. So here's the here's the formula. The amount in the future as a function of time is equal to what we started with, and then it's decaying or declining at this decay rate. And again, this is in decimal form. And so if you turn this into a percent, you would get a decline of about 3.2% per year. And they give me the number of years. So this is going to be a pretty simple problem, right? We're just going to simply fill in the blanks. And by that, I mean, we're going to just do this. We're going to say this is negative 0.032 times 40. And we'll use let's just use our calculators to do all of this calculation, so I don't have to worry too much about where I'm going to round it. So all I'm going to do now is just put in the 200. I'm just trying to hold us where you can see what I'm doing here as best we can. So I'm just going to put in 200 times, and it's e to the what? Second e, negative 0.032 times 40. Okay, and so that should give me the answer of the quantity that's going to be left. And I hit enter. And I get this answer. I get 55.607 and some more. And they wanted me to round it to the nearest whole gram, so the answer is going to be 56 grams. And so is that an answer choice we have? It is. So the answer to this one is B, 56 grams. So that was pretty simple, wasn't it? Now I want to just come back and comment a little bit more on this. Now, generally, when we're working these problems, we're going to simply always use the negative exponent as a decay factor or a reduction factor. Usually it's referred to as a decay factor. But if I were to write this in fraction form, e in fraction form, remember how that would look? Well, it would be 1 over e to the 0.032 times t. And you say, okay, so what if you in fact did this? What would this value be when you say 1 over e to the 0.032 times t? Well, you would get a fractional value, obviously, right? So let's just see what it would be. It would be 200 times 1 over, and so what is that going to be? Well, we're going to use the numbers we're given, and so it'll be 1 over e to the, now notice I'm going to change my sign here to a positive value, right? Why? Because I'm writing it as a fractional value, and so this is the denominator. So at any rate, what are we going to get? We're going to get 1 over e to the 0.032 times 40, which is, what is that, 3.59? So it's 1 divided by 3.5966. And what is that? So let's just divide that out and see what we get. We get 1 divided by 3.5966, and I get that this value is 200. And in decimal form, now I'm going to go to decimal form just for a second. It's 200 times 1 over, what, 0.28? When I round this, I'm going to round it up to 0.28, okay? Which is, bear with me for a second now, I'm continuing to go here. So I'm going to rewrite this as 28 hundredths, right? And then furthermore, I'm going to quit here a second. I'm going to simplify this fraction as what? Well, let's see, I can put a 4 into here and get 5, and a 4 into here and get 25. So it looks like it's about 200 times what, 1/5? Is that making any sense to you? Well, that was 28. Let me do that again. So that was not 20, that was 28 hundredths. So that would be 7 over 25. All right, 4 will go into 28. 7 times 4 will go into 100. So then this as a fraction would be 200 times 7/25, approximately. So we're going to lose something. We're going to lose a little bit when we do this rounding. You know, I just kind of cut to the chase on this, do some rounding here. Not too much, because think if I multiply this out, what am I going to get? Well, 25 will go into 200 how many times? 8 times? Yep. And 8 times 7 is 56. And I'll be darned, that's what the rounded answer was up here, was 56. So again, don't get confused when you see the exponent being a negative value on e. That does not mean that the base is negative. It simply means that that gives me a way to express e, which is normally a positive value, a whole number. And what is e normally? Well, e is normally 2.7828. But now I can put it as 1 over that and turn it into a fraction so that I can make these decay problems work. Okay, so what did we say the answer to that one was? We said the answer to that was 56. And again, now, this is a pretty simple problem. All you have to do is just understand what the numbers represent. And in this case, all we had to do was just plug in the time value that was given to me, 40, and then do this calculation. And I find that I'm going to have about 56 grams left.